Also important to remember, the having clause filters grouped results only. What this means is that you want to make sure that you don't mix up filtering between the where clause and the having clause. The where clause acts on the query as it's being executed. In other words, it doesn't return all the data. It doesn't read everything. If you say go and select 10 rows from a 1 million row table, the where clause will cause the select to actually read those 10 rows. If you said go and put the filtering for those 10 rows in the having clause after the group is set up, in other words, you pull the groups out, you're going to retrieve the million rows, you're going to apply whatever where clause you have, and then it's going to group or aggregate using the group by clause and then strip out the resulting groups that you don't need. Remember, there are many situations where you can actually push the filtering back into the where clause from the having clause. Group results are filtered using the having clause. In other words, the aggregate groups that result from a group by clause. So, how can I demonstrate the having clause? Let's take this query. Here I'm actually selecting and aggregating by category. So I'm going to find each category ID and the count of each category in this table. In other words, there are 30 rows in the show table with category ID value 6, etc., etc. Here what I've done is I've said where category is less than 100, and let's go back to the text because it's gone off the screen, where the category ID is less than 100, and I've grouped by category ID. This is correct because I have filtered out the rows that I don't want first. I only want to count rows that have this ID value less than 100. In this second query, I'm actually passing this filter into the having clause. It will function, but the problem is it's not filtering out less than 100 first. If I have a million rows in this table, it's actually going to read all 1 million rows, group them, and then pull out the category IDs based on this first column. It'll only return rows that have category ID less than 100. So if you can imagine, if there are 900,000 rows greater than 100 or greater than or equal to 100, then I'm actually still going to read a million rows, and I'm only going to return an aggregation of 100,000 rows. That's a lot of wasted I/O time. And as you can see, this query returns exactly the same result as using the where clause. So the having clause does not apply in this situation. Where the having clause does apply is in this situation. What I'm doing is I'm returning the category and the count from the show table. I'm grouping by ID, and then I'm saying that the result of the count, in other words, how many categories I have of a specific category ID, add up to more than 30. As you can see here, I'm actually filtering the resulting group of the group by clause. So if I copy and paste this query in and execute it, you can see I'm only returning a single row because there is only one category that has more than 30 occurrences in the show table. Use functions sparingly. Avoid use of functions in the where clause and in having clause filtering. You can use function-based indexes. However, the problem with function-based indexes is if they are in the hands of developers, they can quite often result in a proliferation of indexes created for whatever SQL code statements people are writing. That's one danger that a DBA should actually watch out for. It's sometimes better to create function-based indexes in the tuning phase, more or less when development is fairly well complete, in order to avoid a situation of too many indexes. If you have 5 indexes on one table, every insert is going to insert into 6 objects. One table and 5 indexes. If you have 1 index and 1 table, you only add basically to 2 objects when you insert a row. If you have 50 indexes on a table, obviously every insert is inserting 51 occurrences, and that is a serious problem for performance. Use sequences. Oracle contains a thing called a sequence, which is essentially what some databases call an auto-counter. It's an internal auto-counter, it's an object. Many applications use centralized system tables for applications containing sequence numbers, and they have some serious hot block issues when accessing a small column from a group of small columns on a single record in a single block in a table. Use the sequences to count values.